Good morning, students. This is Bhavna Sinha, your chemistry teacher, and this is the fourth video for this week. As you all know, we are discussing the chapter P blocked elements, and in that, we are discussing about the group 16 elements. So, here we go. Today, we will first of all discuss about the oxidation state. So, the group 16 elements have a configuration of NS2NP4 in their outer shell. They may accomplish noble gas configuration either by the gain of two electrons, by framing M2, or by sharing of two electrons. In this manner, shaping two covalent bonds. Thus, these elements indicate both negative and positive oxidation states. That means the elements which are present in group 16, they show positive oxidation state also, and they show negative oxidation state also. And what is the range of their oxidation state? It is -2, +2, +4 and +6. That means the members of group 16 elements, that are oxygen, sulfur, selenium, tellurium, polonium, they exist, they can found or they can show these four oxidation states, that are -2, +2, +4 and +6. They can fulfill their stable configuration either by the gain of two electrons or by the sharing of two electrons. Either they can gain two electrons or they can share two electrons. Let us see some example. One example for this. For example, we are taking the example of uh, two compounds like Na2O. The first one is Na2O. Okay, and the second one which we are going to discuss is CO2. Very simple it is. Okay, now you can see in Na2O what happens. Two Na atoms are there. Okay, one Na atom and second Na atom, and one oxygen is there. Now Na has one electron, it has the configuration of 281 because its atomic number is 11. 281, and it has 2 6. So this one electron gets transferred here, this one electron gets transferred here, and in this way what happens in Na2O, you can see this is Na, this is O. So one electron gets transferred, another electron gets transferred. Both the sodium atom transfers one electron to the oxygen, and in this way oxygen gains two electron and the formation of Na2O takes place. Okay, so in Na2O the oxygen is gaining two electrons, one from each of the sodium atom. Okay, now let us see the condition of CO2. So what happens in CO2? You can see CO2, carbon is also nonmetal, oxygen is also nonmetal. So anyone cannot lose any electron, so both will share electron. Now how this sharing takes place? Carbon shares its 2 electron with both the oxygen atoms. Okay, this is the electron of carbon and this is the electron of oxygen. So this is the covalent bond, and again this is oxygen electron, this is carbon electron, and in this way it becomes stable, and carbon also becomes stable like this. So this is sharing of electrons, and in sharing of electrons here oxygen is sharing two electrons with the carbon atom to become stable. So what is the bonding? How can we show bonding in this? You will see here CO2, C, double bond O, double bond O. Okay, so this is covalent bond which is formed by oxygen with carbon, and in the earlier in Na2O we have seen the gain of electron. That means oxygen, one of the examples of group 16, it can share as well as it can gain 2 electrons. Now oxygen shows high electronegativity. In all its metal oxides, oxygen demonstrates a negative oxidation state of -2. Despite -2 oxidation state, oxygen illustrates -1 oxidation state in peroxides. Okay, like you can see the example of H2O2. What is the name of this compound? It is hydrogen peroxide. Okay, and here the two oxygen atoms are present, you can see here. And when we will find the oxidation state, we will just divide it, multiply it by 1 by 2. So 1 by 2 into 2, it is 1. So the oxidation state shown by the oxygen in peroxide is -1. Here it will be -1 by 2 due to its spin, opposite spin. So it is -1 oxidation state. Okay, so oxygen can form -1 oxidation state also in case of peroxides. The different peroxides which are formed by oxygen with different elements, it can show -1 oxidation state also. And in superoxides also it can form different types of oxidation state, you can see in this diagram. Okay, so O2, you can see the first one is, and the second one is superoxide anion. Okay, superoxide anion, and the next one is peroxide anion. So you can see O2 is a molecule, O2 minus is an anion. Now what is the meaning of anion? Anion which is formed by the gain of electron. When it is gaining electron, then it is developing negative charge, and due to the development of negative charge, it becomes anion. So superoxide anion is O2 minus. And what is peroxide? O2 2 minus. In peroxide, what is the oxidation state? O2 2 minus. And here you can see I have also given the example of hydrogen peroxide, H2O2, how it is formed. Both the oxygen atoms are present in the middle, and one electron they are sharing with hydrogen. Two hydrogen atoms are there, and one electron is shared between both the oxygen atoms. So this is hydrogen peroxide, or you can say peroxide. Okay, and then hydroxide ion, which is also known as hydroxyl ion. Hydroxide ion, which is also known as hydroxyl ion, you can see OH and OH minus. Okay, so hydroxide ions show one negative anion. That means they have to gain one electron, and this they can do by sharing also, or by directly gaining from some other ion or from some other atom. In any way, if they are gaining one electron or if they are sharing one electron, then they will become stable. Okay, you can see the difference between oxygen, superoxide anion and peroxide. Very interesting it is. O2 becomes a molecule when it is oxygen, dioxygen. It becomes an anion. It becomes an anion when it is O2 minus, and it is superoxide ion. And here the oxidation state of oxygen in O2 minus, that is in superoxide anion, is -1. But in case of peroxide, that is O2 2 minus, what is the oxidation state of oxygen? It is -2. You can see the difference between superoxide anion and peroxide anion. Okay, superoxide oxide anion has -1 oxidation state, and peroxide anion has -2 oxidation state. So this is very notable point here. What is the difference between the superoxide anion and the peroxide anion? So the -1 and -2. Oxidation states are shown respectively in superoxide anions and peroxide anions. Rest we will discuss in next class. Thank you.